Hi, today we'll be learning about the construction of LALR1 parse table. So, for that, the grammar given is this. So, for the given grammar, that can be written as an augmented grammar form, which is S dash representing star S. So, the following augmented grammar, when taken in canonical set of terms, LR1 can be represented as I naught representing S dash represents star S comma dollar, S representing I C T S comma dollar, S representing star I C T S E S comma dollar, and S representing star I comma dollar. Generally, instead of star, we can also use dot, but here we have taken star for our convenience. So, for the rule S star over here, which is taken as S dash representing star S, the corresponding rule for that is A representing alpha star X beta comma A. So for that, alpha equal to epsilon, X equal to S, beta equal to epsilon, and A equal to dollar, being its initial rule. So applying the closure rules on S, we'll be getting I1, where I1 will be going to I naught comma S, S dash represents star S comma dollar, I2, where I2 will be going to I naught comma I, S will be going to I star C T S comma dollar, and next step S gives us to I star C T S E S comma dollar, and whereas C star B comma T, I3 will be going to I naught comma A, so therefore S represents A star comma dollar. I4 will be going to I2 comma C, so therefore S represents I C star T S comma dollar. Next step, S representing I C star T S C S comma dollar. And coming to I5, which will be going to I2 comma B. So therefore, C represents B star comma T. Now, I6. I6 will be going to I4 comma T. So therefore, S represents I C T star S comma dollar. Next step, S represents I C T star S E S comma dollar. Next step, S represents star I C T S comma dollar or E. S represents star I C T S E S comma dollar or E. And next step, S representing star A comma dollar or E. Now, going to I7. I7 goes to I6 comma S. So therefore, S represents I C T S star comma dollar. And next step, S representing I C T S star E S comma dollar. So the following canonical rules which have been applied on S, where the closure properties are explained. So now we need to merge. In order to merge the states having common first component but with different second component, the condition criteria for merging. So therefore, now let's see by merging 2 and 8, I2 8. So therefore, S represents I star CTS comma dollar or E. Next step, S representing I star CTSES comma dollar or E. Next step, C representing star B comma T. Now let's merge the states 3 and 9. So therefore, I3 9. S represents A star dollar or E. Next step, merging states 4 and 11. So therefore, I4 11. In I4 11, S represents ICTS comma dollar or E. Next step, where S represents I C or TSES comma dollar or E. Now merging states 6 and 13. I6 13. S represents ICT star S comma dollar or E. Next step, S representing IC star SES comma dollar or E. Next step, S representing star ICTS comma dollar or E. Next step, S representing star ICTSES comma dollar or E. Following the steps of I613, we'll be concluding it with S representing star ICTSES comma dollar or E, and next step, final step, which is S representing star A comma dollar or E. Now Let us merge states 7 and 14. I7 14. By merging states of I7 of 7 and 14, we'll be getting S representing ICTS star comma dollar. Next step, S representing ICTS star ES comma dollar. Now let's see by merging states 10 and 15. So by merging states 10 and 15, I10 15, where S represents ICTSE star S comma E or dollar. Next step, S representing star ICTS comma E or dollar. Next step, S representing ICTSES comma E or dollar. Next step, star A comma dollar or E. Now by merging states 12 and 16, where I12 16, so therefore S represents ICTSES star or dollar or E. Now as you can see, the merging has finished. The following table can come by taking the actions on merge states and following the closure rules and the canonical form. By applying all these three, the actions will be taken and the table can be constructed, as you can see here, with the following states representing and the following inputs taken. Thank you.
Hello, today we'll be talking about the models of activation record. The models so far are lexical analysis, syntactic analysis, and semantic analysis. Basically, lexical analysis detects the inputs with illegal tokens, and syntactic analysis detects the inputs that have ill-found parse trees. And finally, we have semantic analysis. This basically just catches the errors that haven't been caught in lexical analysis and syntactic analysis. So now the goals of semantic analyzer are just to find the remaining errors that haven't been caught in lexical analysis and syntactic analysis. Then these can be the undefined variables and types, and these types of errors can be caught statically. And we have two types of checks. One of them is static checks and dynamic checks. Static checks is basically done by the compiler, and dynamic checks is done during runtime when a user is trying to run an application. Scoping. Scope rules of a language. These determine which declaration of a named object corresponds to each use of the object. And in this we have two types of scoping. One of them is static scoping and the other one is dynamic scoping. Static scoping is basically the scope is determined during the compile time, and dynamic scoping is in which the scope is declared during the runtime. C++ and Java use static scoping. Lisp, APL, and Snowball use dynamic scoping. Symbol tables. So now the basic purpose of symbol tables is to keep track of names declared in the program. So the symbol table entries associates a name with a set of attributes. So these are basically the kind of names, the types, nesting level, and the memory location inside the main memory. And implementation of symbol table can consist of a hash table, basically this consists of all the names, and also a stack to keep track of all the scopes. A hash table is basically allocating data into a certain table based on the key values, and whenever the location are clashing, we have to use a linear programming to make sure that the data isn't clashing. Type systems. A language type system specifies which operations are valid for which types, a set of values, a set of operations allowed on those values. The goal of type checking is to ensure that operations are used with correct types. Enforces the intended interpretation of values. Next is type inference. This is the process of filling in missing types of information. So now this diagram shows what happens to the source code and how the code is generated. Basically we input the source code, and from this, after lexical analysis, we find out the lexical errors or the wrong tokens, and after that we have syntactic analysis. In this we find out the syntax. In this we find the syntax errors. And after that we have semantic analysis. This analysis basically catches the remaining errors that haven't been caught during the lexical analysis and syntactic analysis. And after these three analyses, we have basically the code is generated. Activation records. A procedure is a control abstraction. It associates a name with a chunk of code. That piece of code is regarded in terms of its purpose and not of its implementation. A procedure basically creates its own namespace. It can declare local variables. Local declarations may hide non-local ones. Local names cannot be seen from outside. Control abstraction. Procedures must have well-defined call mechanisms. In many languages, a call creates an instance of the procedure. On exit, control returns back to the call site to the point right after the call. Use a call graph to see set of potential calls. Handling control abstractions. Generated code must be able to preserve the current state, save the variables that cannot be saved in registers, save specific register values, and establish procedure environment on entry, map actual to formal parameters, create storage for locals, and restore previous state on exit. Local variables. Functions have local variables. Created upon entry, several invocations may exist. Each invocation has an instantiation. Local variables are destroyed upon function execution. Happens in a LIFO manner. What else operates in a LIFO manner? A stack. A stack operates in a LIFO manner. LIFO is basically last in, first out. So this means that the data that is inserted last is removed first. Stack frames. So the basic operations of stack frame are push and pop, and these happen way too frequently. Local variables can be pushed and popped in large batches on function entry and exit. Instead of using a big array with a stack pointer garbage beyond the end of the SP, a frame pointer indicates the start for this procedure. Stack frames. Activation record or stack frame. These store the local variables, parameters, return address, and temporaries. The frame size is not known until late in the compilation process. Thanks so much.